All right, hello friends. Welcome to Mathematics Made Easy tutorials YouTube channel with Maths Doctor. Today we are looking at 20 problems on calculus. 20 problems on calculus. And first on the list, we are looking at y equal to 1 plus tan x all divided by y minus tan x. Of course, this is a problem of u over v. It's a quotient problem. And of course, from our previous video, we have looked at the techniques of differentiation. Maybe I'll drop the link in the comment section so that if you have not watched it, go and watch it. We have looked at the techniques of differentiation. Now, in trying to differentiate this quotient related problem, all you do is start with the denominator v, keep the v as constant. That's what we have just done. That is 1 minus tan x. Differentiate your numerator. Differentiating numerator, differentiating 1 is constant, which is 0. Differentiating tan x, we have sec square x. Minus, this time around, keep your numerator as constant. 1 plus tan x. Now, differentiate the denominator. 1 again is constant. Minus tan x give us minus sec square x all over the denominator square, of course, which is 1 minus tan x all squared. Further simplification gives, of course, sec square x times 1. The result is here, sec square x. Sec square x times minus tan x, that will give us minus tan x sec square x. The second part of the bracket, minus 1 times minus sec square x, that will give us plus sec square x. And of course, minus tan x times minus sec square x, that will give us plus tan x sec square x, all over 1 minus tan x all squared. Carefully looking at it, you see that we have opposite signs. Here is minus and here is plus, and they have the same terms. So minus tan x square x will cancel out with plus tan x and sec square x, leaving us with just sec square x and under sec square x. That is double of it, leading us to the result 2 sec square x all over 1 minus tan x all squared. Yes, that's the result for problem number 1. Now we are looking at number 2 right away. Number 2. Now, given y equal to 1 plus x squared plus x raised to power 4 all divided by 2 plus x raised to power 3. Again, this is a case of u over v. The same principle, the same approach. Of course, our result y prime dy over dx equal to, keep your denominator, which is 2 plus x raised to power 3. Differentiate your numerator. 1 is constant, 0. Differentiating x squared, we have 2x. Differentiating x raised to power 4, that is 4x raised to power 3. Then minus, of course, we are keeping this time at the numerator, which is 1 plus x squared plus x raised to power constant. Differentiating now the denominator, 2 is 0 constant. Differentiating x, we have 1. Differentiating x raised to power 3, we have 3x raised to power 2. All over denominator square, of course, 2 plus x raised to power 3 all squared. Now, expanding further, we have 2x times 2, that is 4x. 2x times x, we have 2x raised to power 2. 2x times x cubed, we have 2x raised to power 4. Y3 and 1 raised to power 4. They have settled 2x. Using now 4x raised to power 3. 4x raised to power 3 times 2, we have 8x raised to power 3. And 4x cubed times x, we have 4x raised to power 4 plus 4x cubed times x cubed. That gives us 4x raised to power 6. We have settled the first bracket. Now on this part now, we have 1 times minus 1 giving us minus 1. we have 1 times minus x squared. All right, sorry for that break in transmission, of course. So again, look at it. Minus 1 times minus 1 times 1, we have minus 1. We have minus 1 times 3x squared. We have we have minus 1 times 1, we have minus 1. We have 1 times minus x squared, we have minus x squared. We have 1 times minus x raised to the power 4, we have minus x raised to the power 4. We have 3x squared times minus 1, that's minus 3x squared. And 3x squared times minus x squared, that giving us minus 3x raised to the power 4. And of course, 3x squared times minus x raised to the power 4 is giving us minus 3x raised to the power 6, of course, and then all over 2 plus x raised to the power 3 all squared. All right, collecting items, you can see the only constant we have is minus 1. Minus 1, next is x. We have 4x going through no other x, so we have plus 4x. Next is x squared, so we have 2x squared combining with minus x squared combining with minus 3x squared, so that's giving us minus 2x squared. Then for cube, we have only one term, 8 x raised to the power 3 plus 8x raised to the power 3. For power 4, we have plus 4x raised to the power 4. Going through it, minus x raised to the power 4. Going through it again, we have minus 3 raised to the power 4. Combining, give us plus 2x raised to the power 4. We don't have power 5. The only thing we have is 6. Going through there, plus x raised to the power 6. And then we have minus 3x raised to the power 6. Combining, we have just x raised to the power 6 all over. All right, so we'll look at. All right, number 3, y equal to 3 plus 4 sine x divided by 4 plus 3 sine x. Of course, this again is another case of u over v. U over v. So our dy by dx or y prime, the derivative, equal to the same principle, keeping the denominator 4 plus a constant, 4 plus 3 sine x, differentiating the numerator, 3 is 0, sine x equals cos x. Of course, we have a coefficient 4, so differentiating 4 sine x, we have 4 cos x minus, this time around, keeping numerator constant, 3 plus 4 sine x, differentiating the denominator, which is 4 is 0, sine x, differentiating sine x, we have cos x. So we have 3 cos x, 3 cos x from the result of 3 sine x, of course. Of course, all over v squared, so that is 4 plus 3 sine x all squared. All we did was to carefully open up the brackets. You have 4 cos x times 4, that is 16 cos x. 4 cos x times 3 sine x, that is 12 sine x cos x. Then we have 3 cos x times minus 3, that's minus 9 cos x. Then 3 cos x times minus 4 sine x, that's minus 12 sine x cos x. Carefully looking at it, you see that plus 12 sine x cos x will cancel out with minus 12 sine x cos x. All we have is 16 cos x minus 9 cos x. They are like terms, so we combine them, 16 minus 9 giving us 7 cos x, all divided by, of course, 4 plus 3 sine x all squared as our final answer. That is number 3. Of course, you're making good progress, right? Please subscribe to this channel, share and like, and recommend this channel to friends. You know that you have great need. All right. Number 4. Number 4, out of the 20 problems I'm looking at, number 4, y equal to 3 sine x 2x sine 2x plus cos 7x all raised to power 10. Y equal to 3 sine 2x plus cos 7x all raised to power 10. Quite challenging, right? But very easy. This is of more of a chain rule. So please refer to our video on the techniques of differentiation, more of chain rule. Now, we have a function of a function. So if in this case a triple function of a function, this 2x function of a function, 7x function of a function, raised to power 10 function of a function. So let's go. 10 will be multiplying, and of course reduce the 10 by 1, going to be 9. So we have 10 raised to power 9. Then for the bracket now, the sine function, differentiating 2x, you have 2 times 3, that was the differentiating sine function, you are going to have cos. So we have 3 times 3 is from the coefficient here, 2 is from 2x. 3 times 2, cos is from sine, cos 2x, plus differentiating 7x, you have 7, differentiating cos, you have minus. So 7 into minus sine 7x all raised to 9. Why 9? Because 10 will reduce by 1. Of course, 3 times 2 is 6, cos 2x, then plus times minus, minus 7, minus 7 sine 7x. So the final results are what I'm looking for. Y prime equal to 10 into 6 cos 2x minus 7 sine 2x. Quite easy. Try it. Drop your comment in the comment section. Thank you. See you in the next